So we all know that NodeJS is single-threaded. This means that a NodeJS program execution takes place one line at a time from top to bottom. And this execution is handled by the event loop. This event loop handles asynchronous network operations very well. Their execution is moved aside from the main thread to a different location and handled separately behind the scenes. Once it gives a response back, it's moved back into the main thread. I'll be making a detailed video on the event loop soon, so do subscribe for that. Now, when there's a synchronous block in the thread or an operation that takes up a lot of CPU resources, like say for instance encryption or decryption using a library like crypto, it's going to block further execution. Tasks like these need to be offloaded to a different process or a thread to keep the main thread free. In this series, we'll be taking a look at a bunch of ways to achieve this so-called multitasking in Node.js, starting with child processes. Now, before even getting into a child process, let's understand what exactly a process is. So a process is not necessarily a node-specific concept. It's basically an instance of the program you run on a system. So whenever you run an application, for instance Chrome or a game or even VS Code for that matter, a running state of this application is called the process. Similarly, an application created in Node.js will also have a process when it's executed. When you create a Node.js application, you can get access to the process information by using the process object. It's globally available, so you don't have to require it manually before using it. So if I just console log the process object over here and try to run this file, you'll see all sorts of information over here, and all this information is associated to this process object. This object has details related to the application, the operating system, the device, and much more. I'll probably have a separate video specifically for this process object in the future because it's actually quite interesting. But for now, let's come back to multitasking. Now there's a possibility that somewhere in your program you could have blocking code. This will stall the process when it's being executed, and we don't want that. So Node.js provides us with a module called childprocess, which can spawn up new subprocesses to the main or the parent process. By creating a separate process for a certain task, you are essentially offloading heavy operations, which in turn will avoid any blockage in your main process. There are essentially three ways to create child processes in Node.js: the spawn, the exec, and the fork methods. The spawn function will run a command in a process. After running the command, the data that gets returned from that command will be in the form of streams. This means that it's purely going to be asynchronous. Whenever a piece of data is ready to be sent back as a response, it will be passed to the standard output stream, and if there's an error while running the command, it will be passed to the standard error stream. Okay, so to use the child process module, actually to use the spawn function, you first need to import it from the child process module. So spawn acquire child process. This child process module, by the way, is natively present inside Node.js. Let's first try to execute a basic command. So we'll be listing a few files in the terminal using the dir command. So you normally use the ls command in Linux to list down all the files inside a particular directory. But since I'm using a Windows system, I need to use dir because that is how you list down files in a Windows system. Now if I go down, I clear the terminal, and if I run this, I will get an error. Now the error is a bit vague and you won't seem to understand it right away. The problem is, in case of Windows systems, You need a shell before you try to run certain scripts. This might not happen in case of Linux systems, but it does happen for Windows. So there are two ways for you to fix this. The spawn method, if you take a look at it, has some extra parameters. There's an options object here which takes in a bunch of configurations. So inside the options object, I can just pass in a shell property whose value is going to be boolean. So I can just set it to true. So this is one way of solving the issue. It's basically telling the spawn function to open up a shell and then run this command inside that shell. So now if I clear this and run the script again, now the error is gone, but I don't see anything. I'm supposed to get a list of all the files and directories in the folder, but there's nothing displayed on the console. This is because, as I mentioned earlier, the spawn method returns data via the stream API. So the data that we get is going to be in the form of chunks. So in order to know when a chunk is ready for us, we need to listen to the stream. The way we do this is by using the standard output stream for the valid response and the standard error stream for errors. So I'm just going to copy two lines here. This first line here is going to listen to any error bits that are coming from the standard error stream, and the second line here is going to listen to the output coming from the standard output stream. So let me just run this once again, and you can see that we are getting a buffer string here. So to convert this into a more readable format, you can just use the toString method on your data. So I'll just add this here and save it. Now if I try to run this, I get the valid response. That is how you normally run child processes with the help of spawn. You should also ideally listen for errors that occur when the spawn function itself ran into some issue. So not this command here. The dir command, if it gives an error, that error you get in the standard error stream. But if the spawn function here runs into some issue, you need to listen for that as well. So the way you do that is by listening to the error event. So by using this line here, you can simply listen for any errors that you get while running the spawn function. I hope you understand the difference between this error and the errors that you get inside the standard error stream. Now what if you want to pass in arguments to this command? So you have an option here, which is going to be the second parameter. Inside this, you just pass in an array of all the arguments that you need to pass for this command. So in this case, let me just pass in the b argument, which is going to return a concise view of this listing. So it's not going to show you the time, the date. All it's going to show you is the name of the file. So if I run the script now, you can see that it just shows the file names inside this directory. So that's how you pass in arguments for your commands when you're using the spawn function. Now the problem that we had faced earlier with respect to the shell, I had mentioned that there were a couple of ways to solve the problem. The first way that we saw was this options object. Now the second way of fixing this is by using the exec method. So let me just import it first from the child process module. This exec method might not look that different from the spawn method, but they indeed are very different. The very first difference is that exec will always first open up a shell and run your command inside that shell. So the fix that we had found for the spawn function, the options object where we passed in the shell property, the exec function does it by default. You don't have to pass in any shell property to the exec function. It will just open up a shell and run the command inside that shell by default. So I'll just comment this out and just type in exec, and we'll run a separate command this time. So what we'll do is we'll try to copy the values of the file inside this script.js file, into a new file. So I'll just have script.js first and dummy file.js as the second argument. And you can also observe that in case of spawn, we used to pass in the arguments inside this array over here, but exec has no arguments. It takes the whole command string as it is. If you want to pass in arguments, you pass in inside the command directly. So the command here is the copy command, and the arguments for this command are these two files. In case of Linux, you would normally use cp instead of copy. Just because I'm on Windows, I need to use the copy command. Now if I save this and I'll clear the terminal first and I'll try to run the script. Again, I don't get anything here, which brings me to the third and the most significant difference between the exec method and the spawn method. The spawn method used to return data in the form of streams, which is why we had to listen to the standard output and the standard error stream. So anytime we got a chunk of data from those streams, we used to display them inside the console log statement. Now in case of exec, what happens is behind the scenes there's a buffer storage. Inside the buffer storage, all those chunks are stored, and only when the whole response is fetched will you get the response. So it's going to store all the chunks inside that storage, and after that at the end it will return the whole piece of response together. So in case of spawn, there was no limit in the size of response because it was sent back in chunks. You could potentially get a huge response over a period of time. In the case of exec, it waits for the buffer to be filled first. Once it's filled, it will return the whole response back. So that's obviously an issue here, because what if the size of the response is greater than the buffer? Your application will simply crash if that's the case. So if you know beforehand that your response is going to be huge, you should opt for the spawn method instead of the exec method. Yeah, coming back to the code, instead of listening to the standard output and standard error streams like we did in case of the spawn method, we now get them inside a callback function. Inside the callback function, we have three objects: the error, the standard output object, and the standard error object. Now what we are doing here is, we are handling three cases. The first one is the error, and this error is associated with the whole command. If there's a problem executing the exec command itself, then you'll be getting an error inside this block. While executing the command here, if there's an error, then that error will be stored inside the standard error object. And at the very end, if there are no errors, you'll be getting the output inside the standard output block. If I save this and I run the script, I get the response. It says that one file is copied, and if you take a look over here, you can see that there's a dummy file, and if I open this up, it has the same data that I had inside the script.js file. So yeah, that's pretty much how you create child processes with the exec command. Now what we'll do is, we'll try to run one command with the spawn function and the exec function and see how both of them return data. Now we have the exec function here and the spawn function here. Both of these functions will run the node command. So it's going to run the script here. Rest of the things is the same. In case of error in the statement itself, it's going to return the console log statement. Same for the standard error stream. In case of an output, it's going to return the valid response with the exec string over here. Same for the spawn method. Now we need to have this file present inside our directory, so I'll create that as well. This node module file is a simple script. What it does is, it has this interval variable over here. Inside this interval variable, we are setting an interval which is just going to console log the statement. So it's basically acting as a stream. This interval will run for 5 seconds, and after that it will clear the interval, so this whole function is only going to run for 5 seconds. the time difference between each function execution of this interval is going to be 1 second. So you'll be getting this console log statement every 1 second when you run the script. So yeah, everything's fine. Now if I clear this and try to run the file, so as you saw, the time difference between each spawn console log statement was 1 second, but all the exec console log statements were returned together. So this is what I was trying to say. Spawn used to return the data in the form of stream. So anytime it got a value from the node module file, it only then returned the data from the standard output stream. But in case of exec, it stored everything inside a buffer, and at the end of the execution, the file execution, so after 5 seconds, it returned the whole value that was stored inside the buffer. So it had 6 console log statements inside the buffer. After the 5-second mark, it returned everything together. Let me just console log this for 1 second. In case of exec, I had mentioned earlier that that could be a potential problem if the response size itself is greater than the buffer size. In Node.js by default, the size of the buffer is around 1 MB. So what I'll do is, I'll just replace this with a console log statement and copy in a bunch of text which is going to increase the size to more than 1 MB. So I have dummy text inside this file now, and I for a fact know that it's more than 1 MB. So this should give me an error here when running the exec command. So I'll just clear this and try to run the command. I get the error saying that the max buffer length has exceeded. So yeah, this is what I was trying to say. The buffer size itself has a limit. So when the response that it's trying to accumulate over time is greater than the size of the buffer, we will come across this error. So a workaround for this is that I could just simply pass in the options argument here again, and there's a max buffer property over here which can be manipulated. So I know that the file size is 3.5 MB. What I'll do is I'll just set it to 4 MB, and the way you pass it inside this property is in the form of bytes. So 1024 times 1024 is 1 MB, and if I just multiply it by 4, this is 4 MB. Now if I try to run this, I get the whole thing. So yeah, so this is one way of fixing the problem. Or let me just stop this for a second. If you run the same command using the spawn function, this will run right away, because it gets the output in the form of chunks. So it's going to run as it is without any buffer issues. Yeah, you can see that it's running without any issues because the data that you get inside the spawn function is in the form of streams. There is no buffer issue, which is why you get the response as it is. What else can you do with these functions? If you want, I'll just comment this out. I'll just run exec because it's simpler. Instead of this node command, I'll just replace it with, let's say, type. So type basically reads the contents of the file. So if I run this, you can see that it basically printed the contents of this file itself. I can create directories using childprocess. So mkdir test dir and save this. If I run this now, you can see that there's a directory over here inside our folder. So that also works. If I want to run applications, I can do that as well. So start, let's say, Firefox. If I run this, I get the Firefox browser window. So yeah, you can see the power that these two commands possess. You can do a lot with these two commands. You can run different kinds of processes. and offload memory intensive or CPU intensive tasks to these child processes. These functions here are asynchronous, so they don't block the main thread. There are two more methods left that can be used to create child processes. One is the exec file method and the other one is the fork method. We'll take a look at them in the next video. If you have any doubts or suggestions, you can put them in the comments below, and I'll see you in the next one.